Hi everybody, welcome to today's webinar. We might just wait a couple more minutes for people to come in and join the webinar. So we'll get started in a few minutes.
Yeah, I think everyone's just starting to trickle in now. Just might get everybody, if you can hear us okay, might just get a couple of people to message in the chat and let us know if our audio is working well. Perfect, it's looking like it is. Awesome, hello to everyone that's coming in now. Just a little bit of housekeeping while we're waiting for a couple more people to join in before we start. If you want to make the slides bigger on your screen, there is the option to close the chat window in the top right-hand side of your Demio browser. It's the little line with the arrow next to the gear. So as we go through the slides, if you want to make them bigger, you can close the chat and open it again if you want to ask any questions.
Yeah, and another note, feel free to, as Tim's going through the presentation, feel free to put in your questions, but do note that we'll answer all the questions at the end. So.
Yeah, look, I think numbers are growing up now, so I think we can probably just about get going, and I'm sure people will slowly start to trickle in.
All right, then we'll get started. So, good morning, everybody. Welcome to today's webinar. This is a really special webinar because we've got a very special guest. Dr. Tim Johnson was very kind to give us his time today and share some of his knowledge in terms of how to pave with trees and better paving solutions for the future. And I'll introduce Tim a little bit more in just a few slides. But before we get started, I'm just going to give a brief introduction as to who we are at the CMAA and what kind of resources that we offer. Before we start, we'd just like to do an acknowledgement of country. We'd like to acknowledge the traditional custodians of these lands from which our presenters and from which our attendees are joining us, and pay respects to the elders past, present, and future. I've got a little video that I'm going to play, just showcasing what we actually do at the Concrete Masonry Association of Australia. So,
the Concrete Masonry Association of Australia is an industry association representing concrete masonry manufacturers. Our mission is to make it easier to build with concrete blocks and pavers, which is why we offer all of our services and resources on a complementary basis to councils. These include our technical services, industry-recognised pavement design software, technical resources, industry networking, technical committees, and our training courses. Our engineers frequently work with masonry products and offer their technical design services to help you effectively manage your projects. We offer industry-leading software tools such as DesignPave and PavMent, which assist engineers and landscape architects in pavement design, alongside live webinars and in-person workshops where we demonstrate how to use the software. We have a range of technical manuals and fact sheets easily accessible from our website to guide your engineers when working with concrete masonry. We facilitate opportunities for you to get in touch with our network of industry members whenever you need to sample their products or receive technical guidance. Another valuable resource is CMAA's Technical Committee, which is comprised of experienced industry practitioners who can discuss any issue in the industry and projects your council is interested in with regards to concrete masonry. We also offer our Approved Installer program, which provides training for engineers and paver installers in segmental pavements. Whether they are in-house or subcontractors, the Approved Installer program can help avoid product failure optimize construction methodologies, and minimize maintenance issues. For all matters related to concrete blocks and pavers, your trusted source of information is the Concrete Masonry Association of Australia. Our mission is to inform, educate, and provide guidance along the way for councils on a consistent basis. Give us a call today and keep thinking pavers.
So that there's just a quick video showcasing what we do at the Concrete Masonry Association. As the industry organization, we help write building codes, we help do research, and we help advocate for building materials and make sure that people are building with the correct and the best practices. Our strategic vision is to make it easier for people to build using blocks and pavers. And we have a range of different strategies to do that, some of which was outlined in the video. If you're curious, if you're a little bit curious about some of the resources we offer, I might just put up a link to our website in a sec. And you can feel free to check out more about what we do. Here are some of the members who do sponsor us and who we do represent. So quite a few members who we consistently work with. And we do have a wide range of resources, whether it's manuals, whether it's training courses, as well as our DesignPave software. I'll put up more links at the end of the presentation in case you're interested. Lastly, before I pass off to Tim, I just want to give a brief shout out to our approved installer program. And this is a free workshop for councils where we do teach, we spend the whole day running through the design and the construction of segmental pavements. And I'll give you guys a link at the end of the presentation as well. But today, what you're probably most interested in joining this webinar is to learn. Hi, Owen. My name's Jim. Sorry, didn't introduce myself. My name's Jim. I also have Jack with me from the Concrete Masonry Association. And today's webinar is very special because we've invited special guest, Dr. Tim Johnson, to join us and talk about paving with trees. Tim has a unique background working both as a civil engineer, but also very experienced in arboriculture. So he can give a lot of different insights about how trees and pavements work together. Tim currently works at the City of Mitcham, but is also a researcher from the University of New South Wales. In any case, I'll pass off to you, Tim, and I'll let you take it away.
Thank you very much, Jim. And thank you, viewers, for tuning in. This isn't going to be so much a lecture or a seminar. It's a recount of some really interesting and fun research we've been conducting for about 12 or 13 years now. It has been surprising, informative, really interesting. I hope you enjoy it. Please don't tune out too early because there is a fair bit of content, introductory content on trees, tree root growth. Really, a lot of the solutions we've been finding have come from understanding how roots do and don't grow. But rather than me parrot on at the start, I think I'll just share my screen if I may.
Yeah.
Done. Which should reduce my mug on the screen quite a lot, hopefully. So thank you, Jim. Thank you, CMAA, for the opportunity to speak with you all today. And thank you to the City of Mitcham and to the Adelaide and Lofty Ranges Natural Resources Management Board, and more recently, Green Adelaide, for the funding they've put into this research over many years. Trees and paving, they don't normally get on well together. and I'm not having any success with the sharing of the screens actually. Yep, but I can't, not having luck with changing to the next slide. I'll just use the scroll button. Yeah, trees generally don't get on well with paving. There's probably no one watching who has not seen this sort of thing or tripped over this sort of thing. Really frustrating, really expensive, really wasteful, and really painful. This tree here is not one that's known for pavement damage. This is a fairly benign species, and this is only 9 or 10 years after, 9 years after that pavement was laid. And you can see root damage tracks along shallow under the paving for quite some distance from the tree. My good friend and colleague Nick Bennett up at City of Mitcham sent me this photograph. These southern nettle trees or hackberry trees are only 8 or 9 years old, and you can see they've systematically written off about half of that footpath over that time. This footpath is no longer an asset, it's a liability because of its relationship with those trees. It's not a good situation, and it's all too common. And up until now, that has been the solution. And that's not a solution at all. This is a different example of the first, one of the first slides I showed you. 9 years after that pavement was laid, that was the result. Tree removed, rip up the pavement, reinstate the base, reinstate. We can't afford to depreciate these pavements over 10 years. We need 40 or 50 years. We can't afford to be planting new trees every 10 years. So as Jim said, I started out as an arborist looking at this problem. And my interests were in the civil side, what happens behind the pavement. So I went back to Uni of SA and did a PhD in civil, looking at the interrelationship between trees, stormwater, soil, and civil infrastructure, looking for some synergies that we can tap into to improve the results and to reduce our costs. This is another example, a large tree on a major arterial, 19 years after it was planted. Small vigorous species, 10 to 20 years, and they're rotting off pavements. As you can see, massive development of large-scale woody roots shallow in the pavement. No way to correct that without removing the tree. Heavy losses, heavy expense, no benefit. And it's not just council street trees, it's trees on private property as well. So why would we even bother planting trees in areas where we need pavements? That's the question. So what I'm going to speak about in the next 3/4 of an hour or so, firstly and very quickly, why we even bother with trees, why do we need them, what trees need to survive in paved areas, permeable paving with a gravel base. Now, the gravel base layer is critical in deterring roots. It's been published over the last 30, 40 years as one of the best root deterrents available, a layer of gravel. That's the key take home. We're also going to have a very brief look at soil moisture and ground movement effects beneath permeable paving, and then whiz through a few quick case studies where permeable paving has been used very effectively. Following that, time for some questions. So why would we even bother planting trees? There's a lot of work being done on human interaction with the natural environment. We evolved as a natural organic system, part of an organic ecosystem. We need contact with nature. There's a lot of work happening in that regard, visually and with the microbes that live on trees and on tree roots. We can't survive without the microbes in our gut. Well, it turns out the microbes in the soil on tree roots are just as beneficial for our health and our immunity, especially this time of the pandemic, that exposure to nature at the visual level and at the biological level of fungal spores from the soil, from tree roots, contacting our skin, contacting our lungs, can affect our mood and our physical health. Exposure to urban greenery can prevent and treat depression. This was a large-scale study conducted in Brisbane, and if the results of that study in Brisbane extrapolate to the whole of Australia, 30 minutes extra exposure to urban green in your street or in your park can reduce expenditure on depression by 7%, which is over $1 billion a year. So a little bit extra green in the cities doesn't hurt. But not just depression. This study in the US, ADHD, exposure to urban greenery, a walk down the street, brushing past a few trees, has a massive effect equivalent to the best chemical drug treatments. Amazing. They haven't put that in dollar terms for Australia yet. That's on the agenda for the next year or two, I expect. But we're talking hundreds of millions of dollars saved per year in treatment in symptoms that don't need to arise. Kids can have a healthier life, adults can have healthier lives because of more nature in our cities. Dementia is a massive problem. It's forecast that the cost of dementia in Australia in 2050 will be 48 billion. And it's related to particulate pollution, fine nanoparticles, microparticles. Trees filter a lot of them from the air. So having a few extra trees in the street, in the parks, even a 1% reduction on 2050 projected figures will save us $750 million. These examples came from a symposium we've just held. TreeNet holds an annual symposium early September each year. The proceedings will be online, free, available as of next January, but there's a lot more information there. That's just a few highlights of the huge financial benefit of getting these trees into the urban areas. But we really need to knock out all the costs. $1 billion, $1.5 billion a year cost to rectify damaged footpaths across the United States when I first started investigating this about 15 years ago. $1.5 billion 15 years ago. So we need to address those sorts of cost impacts to enjoy the benefits. Can we do that? Most people think a tree looks something like that. They don't. That's not a tree. That's half a tree. That's more like what a tree looks like. Think of the microbiome in our gut that nourishes us. The microbiome around those tree roots nourish that tree. Without roots, there's no tree. Here's a take-home quote. Trees don't have teeth. Trees can't chew their food. They take liquid food, slushies, smoothies. They can only intake dissolved nutrients. Soil is generally pretty stable. The nutrients from soil are extracted by typically fungi that live in association with those roots. There's an ecosystem underground there that the trees need to be able to survive. What then happens, we come along in that natural woodland system, a greenfield development. We start to impact the roots. You can see there most tree roots grow up, contrary to popular belief. They need oxygen, they need water. The oxygen diffusion is through the surface, so most roots are near the surface, fairly shallow. They're seasonal in Australia. They grow up in autumn, winter, spring. When it dries out, they die off and grow down to where the water is, so they cycle annually. So most tree roots grow up and they're incredibly fine. All the absorbing roots of trees are about as thick as your hair. Anything thicker is a pipe that transports the nutrients to the rest of the tree. So fine roots are the absorbing roots. Anyway, we come along and we excavate the fine roots and we'll put a road pavement down or dig a trench and put a pipe in and then come along and compact the soil and put a footpath in. So you can see the diffusion is greatly reduced. The tree starts to suffer. The permeability decreases with compaction. The surface is sealed, so water doesn't enter. Gas diffusion is greatly reduced. reduced, trees start to struggle. Trees are dynamic, they do respond slowly. They will grow where conditions support growth. And what generally happens is that growth occurs at the interface of the tree roots and the infrastructure, causes problems. Anyway, that's tree root growth 101. What generally happens under an engineered surface is it's compacted to 95% maximum dry density. So 5% of that soil volume is other than mineral. 5% is left for oxygen diffusion, water infiltration, for the fungi that need to live on those tree roots. 5% is not much. 95% takes up a lot of space. Soil compacted to that extent is impenetrable to root growth. It doesn't allow water through and it doesn't allow oxygen through. Soil compacted to that density does not support tree root growth. So the roots are going to grow somewhere else, typically on top of that subgrade, directly beneath the asset that you want to preserve. Tree roots grow by cell division. The start of our lives, we were a single cell, we divided into two. That's the energy of tree root growth. Single cell dividing into two, right at the tip of these very fine roots. If there's no pore space in the soil, the cell can't divide. If there are two equal pore spaces, one has water, one doesn't, the surface tension of the water draws the dividing cell into it. So roots will track up water gradient. It's not a seek and destroy. There's no such thing as an aggressive tree root. It's a physical response to surface tension of the water. So there's a clue we can work with. If we can get the water where we want the roots to grow, maybe we can solve some problems. So what we need is soil that can support root growth. And there you see some sand under some typical impermeable paving. You can see these white fibres here. That is the propagating root. The extending root is at the tip of those. Sand is very granular, high pore spaces. Roots can easily divide in sand, even if it's compacted under paving. Also, soil is incredibly humid, even in a drought. In the evening, the pavers cool down. We get condensate forms directly beneath the pavers. So putting paving on a sand bedding layer will always support root growth. There's no two ways about it. It's got the porosity the root needs to divide, and it's going to have regular water every evening when the pavement cools off. So if we continue to lay impermeable paving on sand bedding layer, we're going to continue to get tree root problems. There's nothing we can do about it. This is in East Parade, the street. We started some research. We planted these ornamental pear trees in the street, you can see there. But what's interesting here, early days, there's a silver birch in the front garden there. Silver birch don't do well in Adelaide. It's too hot and too dry. The soils are too heavy, solid clay. And you can see here, surface root from that silver birch just creeping its way through under the pavement. If that happens to get through under a pavement, gets into some good soil, fine roots can proliferate, it can start to draw some moisture, that root will thicken and right off the paving. That's fairly standard. It's guaranteed to happen. Here's a close-up, you can see. And you can actually see through here all the secondary and tertiary order roots coming off that main one. They're all on the surface. They're growing horizontally. They can't penetrate compacted soil. And you can see here we washed it out and all roots were on the surface. This is where it starts to get really interesting. That's 95% maximum dry density. Roots can't penetrate. In engineering terms, that's a positive. In horticultural terms, that's a negative. The language between engineering and horticulture is completely different. There's no words that cross over in some of these areas. 95% maximum dry density is growth limiting bulk density in horticultural language. You start to compact, you see these values are quite low. a lot of urban soils are up in the 1.8 to 1.9 tonnes per cubic metre, growth limiting bulk density. If we can avoid compaction, if we can reduce soil strength, we can reduce tree root impacts. Now that's a challenge, but think about that. What trees need to grow is exactly the same as these beans need. They need low strength soils. How can we support low strength soils in urban environments where they've got to support assets? Good question. They need interconnected voids between the mineral grains so roots can propagate and so water and oxygen can diffuse through. Here's this language again. Engineering talks about voids. It implies there's nothing there. Horticulturists talk about pores and air-filled porosity. They acknowledge the air is there. Void suggests the pores are empty, whereas that's the space where the life is, where the fungi, where the bacteria are that need to work in association with the trees to provide their health. So good soils need low strength, interconnected voids, liquid water, oxygen, and nutrients. And that's what got us looking at permeable paving as a way to work with trees rather than to try and persist on the 10 to 20 year cycle of destruction. You understand what permeable paving is. It lets the water through. It's on a gravel base. A couple of points here. Firstly, a subgrade is an option. Most permeable pavements don't need that. That's for higher loads, truck loads. A lot of shopping centre loading areas in the UK have a subgrade, a design similar to this. An underdrain can be valuable in some situations, but isn't essential. Geotextile isn't essential either. The one point I want to make here is this pavement base is designed to support traffic loads on uncompacted subgrade. That's really only been acknowledged in the last 15 or 20 years in the literature. Before that, it was always seal the subgrade if it's reactive, keep the water out if it's clay, because it's too slow diffusion anyway, which isn't true. But only recently has it been suggested, don't compact the subgrade, but design the base to be supported to support the pavement on uncompacted subgrade. That's another reason we started to look at permeable paving. There's a fair bit of history here. It goes back to the 70s. Some environmental health people in Los Alamos had trouble with tree roots getting into nuclear waste and bringing the nuclides and toxins to the surface. A bit of a problem. This is the site of the Trinity experiments, the development of the atomic bomb. They started using rock as a biobarrier to stop tree roots and vermin. Some arborists in the US and Europe and the UK took this on board in the early 2000s, late 1990s, and progressed it under pavement. And that's really what directed us to look at permeable pavement, which has a standard gravel base layer. So it's built on 50 years of research plus. And we established some very small 4 metre long sections in a 2 metre wide verge. You can see the permeable pavement section here, put a tree in the centre. We put 12 of them in that street back in 2009. You can see the gravel base there, standard permeable paving on the top, grouted with 5 to 7 millimetre stone, straight on a level grade with geotextile. After 5 years, we excavated to see how the roots were developing. You can see these fine roots here growing through the gravel. First interesting point there, those roots aren't 5 years old. You can see these fine roots originate from some slightly coarser roots here, 1 to 2 millimetres thick. Very seasonal. These are only a couple of months old, these roots. They're definitely not 5 years old. They don't last that long in the gravel. You can see the close-up here of these fine roots. Again, they're only a few weeks to months old. But what's really interesting here is you see these brown flecks. And here is the longest section that we found in the gravel bases. That's about 25 millimetres long. It's 16 millimetre stone here. And they're dead and they're decaying, and most of them are gone. All that's left are these fragments. This is seasonal turnover of fine roots. Tree leaves only last 6 months to a year. They grow new ones. They shed. It's a bit like hair for us. It's continually growing and removed. Fine root turnover is a natural process, and here we see it under a paved structure. That's quite interesting. And you can see the woody roots ascending through the geotextile, generating those finer roots that come up through the gravel. They grow up through autumn, winter, spring. They die off in the late spring and summer. It gets too hot, too dry to sustain root growth. So gravel is perfect root barrier, especially in hot, dry, semi-arid climates. We didn't stop there though, looking at the gravel base. If you lift the geotextile, see all these tracks where the roots have been. There's very few roots left here, but there's a lot of evidence where they've been. That's just further evidence of this fine root turnover. That's really what we need to work with. If we can restore natural conditions in the pavement base by having it ventilated, allowing water and air through, we can restore this fine root turnover. And it actually allows the surface of the subgrade here to desiccate over the summer as well. So the subgrade surface doesn't support root growth. These roots here are the largest one in the caliper jaw there is 2 millimetre. You can see some are deeply incised. You can see a track through here. It's coloured discoloration, but there's no relief. There's no impression into the soil. As it's rained over the seasons, the water's come through the gravel and washed the soil that was imprinted onto the geotextile back into the slot. Just fine root turnover, just restoring the subgrade how it was. But what's really interesting here is all of those tracks you see have a fine root hole that descends into the subgrade. So this is increasing porosity, it's increasing stormwater infiltration rate, and it's increasing oxygen diffusion into the subgrade. So the permeable pavement is designed using DesignPave and PermPave to be supported by this low strength subgrade. And this low strength subgrade is actually enhancing the stormwater harvesting performance of the work sensitive urban design device off the permeable paving. So got a greater volume of soil, restored soil moisture more quickly because of this porosity, more access to water available to the trees, so less intrusion into people's gardens, broken pipes, those sorts of things. Generally a better system starting to work more naturally. We didn't stop just at the surface though. We excavated quite a few of these systems. This tree here was 5 years old at the time, 5 years since planted. We excavated a trench 1 metre to the south of each tree, and we counted so many roots over so many days you wouldn't believe. You can see this graph here, the standard impermeable paving built on a sand base, pavement surface, there's the subgrade level. Roots are fairly close to the subgrade there. Business as usual, you see some roots right at the interface. They're the ones that can potentially do the most damage early on. Here you see the perm level subgrade surface. So this is the gravel void above that, and the pavement surface on top. There are some roots growing in that subgrade surface, but they're quite fine. If you look at the roots that are thickening, the ones greater than 5 millimetres, they're at substantial depth below that subgrade surface. These are the ones that are going to persist and continue to grow, and they're actually deeper in the subgrade. When we looked at our trial, as well as having the permeable pavement on a level base, we built some with a swale under the footpath. We thought that'll hold a bit more water, it'll drain the water away from the road on this side. So we thought that might be a good option. It turns out it does work. It does deter the root growth, but it's a lot drier under there. We thought it would hold more water, so it'd be wetter. The gravel actually absorbs more water as it comes through. In Adelaide's rainfall, low rainfall, often the water wouldn't get to the soil surface, it'd just evaporate back out. Well, there's always surprises in research. We thought a bigger detention volume would harvest more water. No, it harvested less because 80% of Adelaide's rainfall falls at 4 millimetres an hour or less. So there's an optimum depth for soil moisture for trees versus dry soil for strength versus pavement base. A few factors to consider in here. Anyway, we did the stats on that, and those larger roots, the ones that are over 5 millimetres, you can see there's a much smaller proportion of them under the permeable with level base and under the permeable with the swale than under the standard pavement on a sand base. So in that shallow zone, 0 to 200 millimetres deep, you're getting far fewer large roots. That's of benefit because it's less likely to result in damage to your pavement surface. This is in depth below the subgrade surface, not below the pavement surface. The gravel layer is a buffer on top of this. This is a secondary additional benefit that will save damage to your pavements due to permeable paving. As well as the gravel layer being seasonal growth only, no roots over 2 millimetres, no growth in the gravel will affect the pavement. In the subgrade, you've got fewer large roots and they are deeper. So a second mechanism of protection. These smaller roots, you've actually got more, which is better for the absorption, better for the health of the tree. And the intermediates, again, you've got fewer in the shallow zone and really no different in the others. So rigorous statistical analysis supports that. And you can actually see it there. This is under a level permeable pavement base. You can see there's very few roots anywhere near the surface. The larger roots are down deeper where they're not going to cause any problem. If you prefer the visual example there, or the stats, well, you've got it both ways there. So what does that mean in reality? Well, we came back after 10 years. You can see the trees are quite sizable now. This planting pit is 600 millimetres wide, which is way too small anyway, but very pro tree in Mitcham. We have to find solutions to get trees into small spaces. And you can see there's a very slight ramping right next to the trunk, not much at all. There's centimetres on that scale there. So we persisted with that. We got some funding through the Adelaide and Mount Lofty ranges NRM board. Thank you very much, Sam Phillips. Absolutely wonderful crew to work with. And they let us pull up some perfectly good pavement. And you can see the edge of the header course, very little distortion. And just outside edge of the header course was here. We've still got massive clearance beneath the pavement surface, 80 millimetre brick. I think that's about 150 of gravel plus 30 to 50 of fines on top. So nearly 200 millimetres clear with no roots in there whatsoever. You can actually read the scale there. To the top of the pavement's 260, so 180 clearance. You can see a bit of a bulge in the geotextile there, right next to the tree. That is this large tree root. Instead of growing horizontally, business as usual case, they grow vertically down. That string is the inside of the header course, the tree pit side. You can see the roots grow vertically down, then across the base. This one's thickened and grown, cut the corner, but still pavement very close to a growing, expanding tree. No damage on the pavement, no repair needed, no injury to the tree. Absolutely brilliant. And that wasn't just a one-off. Every example we excavated had similar root growth. You can see very slight damage to the concealed pavement edge, probably lifted a centimetre. Didn't need repair, but we excavated so we can show you the root growth. Vertically down, outside the gravel, and then horizontal under the gravel base. So this works. Repeatable. You do it, this will work. Here's another example. You can see in the residence garden there's a Hills fig here, planted about the same time as our street tree trial. The Hills fig, think Moreton Bay fig. It's a tree of that sort of size, that sort of vigour. The roots are as big, but it doesn't have the big above ground root flanges. Anyway, you can see a little bit of damage to the impermeable paving here, a trip hazard, and you can see the permeable paving has been raised behind our street tree. In close up, yep, quite a substantial trip hazard here. There's the tree in the background, but in the permeable paved section, it kind of ramps up a little bit and goes back down. So we excavated, see what's happening there. Under the business as usual, it's business as usual. You can guarantee this is going to happen. It's quite an expensive and time-consuming and sweaty job to start cutting out roots like this, reinstating the base, relaying your paving. It's a trip hazard, a liability you really don't want. These were 60mm paving bricks. Doesn't quite fit in a 30mm gap. That root is closer to the tree than the one in the permeable paving. On the surface, business as usual. A small, vigorous root, it's only going to grow, only going to get bigger. Under the permeable paving, 80mm brick, you can see from the top of the bricks, we've still got 170mm clearance above a much bigger root. The tree was just out of the shot there. You can see the root heading along the surface. We were watering the street tree, which is in the foreground. That root growing up the water gradient grew straight towards our street tree, but it tracked below the gravel. This was actually one of the swale pavements. You can see the gravel depth increases in the centre, and that root descended. So there are some real clues there to how we can design tree pits with permeable paving surrounds, and perhaps just increase the depth of the tree pit, the gravel around the tree pit, to give us extra protection against the tree roots. All these sorts of examples we were seeing in Adelaide raised the question for me, is it a result of our climate, dry, semi-arid climate? Well, you might know Simon Beecham and one of his former students, now Terry Lukey, academic up at the Sunshine Coast. They repeated this experiment using a melaleuca in the Sunshine Coast, subtropics, humid, 1,500mm a year rainfall, and you can see asphalt, business as usual, exactly the same root development. But permeable paving, this tree here on the left had a 100mm deep permeable pavement, 100mm deep gravel base under the permeable pavement. And you can see the roots have grown under the gravel. This tree had a 300mm deep gravel base. Roots grow straight down, descend at the edge of the gravel, and horizontal beneath the gravel base. So if they were to expand up to a couple of 100mm deep, you can lift a few pavers, scrape out some gravel, relay, no expense or time involved in pruning roots, and reinstating the base or harming the tree. Tree can survive full asset life. Pavers can survive full asset life. Minimal paving. You see it on the right-hand image here. Descending roots at the edge of the gravel and then horizontal in the subgrade. Repeatable, even in higher humidity, 3 times Adelaide's rainfall, with a vigorous species. It works. As we were getting into this sort of research, we heard quite a few concerns and comments that it would be problematic putting water into reactive clay. Our research in East Parade in Kingswood is in moderately reactive clay soil. it has a shrink swell index up to about 4% per PF of soil suction. So moderate reactivity, you'd expect 60 or 70 millimetre movement over the design life of a home. Seasonal movements 30 to 50 millimetres. And we started monitoring soil moisture using a neutron probe. I won't go into the ratios, but basically a higher ratio, higher in the graph, is a wetter soil, lower ratio, drier soil. And our experiment had a variety of different trees in gardens and in the street, and we assessed the soil moisture using, considering the presence of trees as a covariable, because we know trees extract the water. This top graph shows the soil moisture situation under our standard business as usual impermeable pavement, our level swale and our swale permeable pavements, where there are no trees. And you can see the perm level pavement is very slightly wetter, just above. There was a statistically significant difference, but in reality, it's a very small difference compared to the seasonal movement, seasonal variation. So one permeable design was wetter, the other permeable design was drier. That tells us we need to do some more research, and it'll be climate dependent research to determine the optimum depth for integration of nature into the cities. The depth of the gravel base does make a difference, but what's interesting is it can be wetter, can be drier where there are no trees. Where there are a few trees, there's very little difference there. They're virtually identical. But the bottom graph here, where there are a lot of trees nearby, the soil under the impervious paving was generally wetter. Now, there's a couple of reasons for that, we think. One is it doesn't support the fine root growth that absorbs the water. And the other is it retards evaporation. Evaporation in Adelaide is 3 times what rainfall is. So having an impervious ventilated surface, the soil was generally drier on average below the pavement, below permeable pavement, than wetter. So the assumptions that it will always be wetter under permeable paving because it lets the water in, it's just wrong. We monitored these seasonally 4 times a year minimum, sometimes up to 8 times in some years. Soil moisture down to 3 metres deep every half metre. And there was one occasion over 5 years of monitoring where the soil moisture was greater at half a metre deep below permeable paving than below impermeable. And that was immediately following the wettest start to the year on record. January and early March had really heavy rains. So our early March measurement showed wetter half a metre below the permeable paving. Every other measurement over nearly 5 years, it was drier below permeable pavement, even in the winter. So water into reactive soil and even into low permeability clay isn't a problem under permeable paving. You don't need to line it, you don't need to seal it. You can if you want to harvest the water, but there's no need to, even on reactive clay. We published those results, you can get them online. How that relates to ground movement, my friend Tony on the staff there, he used to come out and help. No, never mind. But you can see the starting position at the start of the study, the greatest heave and the greatest settlement seasonally over the few years. A bit of a break in data there, I got a little bit crook. But you can see where there are no trees, there's slightly more movement from bottom to top at the permeable, but it's not much. But you can see where there are high trees, it's the high shade cover, a lot of trees, it's the business as usual pavement which moved more. The sealed pavement moved more than the permeable pavement where you have trees nearby. Now think about that. We all know trees take water out of the soil, so you get increased settlement in summer. And that's where most of the movement occurs in arid and semi-arid climates. By allowing a little bit of water in during the winter, we reduce that summer settlement. But you can see greater summer settlement in business as usual pavement. So again, contrary to expectation, research always brings up surprises and always makes it fun. A couple of papers from 2010 and 2006, our research just supported these. We were analysing our results at the time these came out, and it was really helpful to see other people are finding the same sorts of things. Even on low infiltration rate, heavy clay soils, you can get good infiltration, and we added to that it won't affect reactive soil harmfully. And if you've actually got trees nearby, it will reduce the amount of ground movement over the year. So that got us thinking, how should we progress with this knowledge? On the left, you've got business as usual, impervious paving 9 years after construction, and that tree 9 years old. Lots of trip hazard, lots of damage, lots of waste. Do we want to pay more for tripping hazards, for short tree and pavement life cycles, for puddles? Do we want increased risk and expense? And do we want to pay more for it? Or on the right, we can avoid puddles, we can avoid hazards, we can have longer tree and pavement lives, we can reduce risk and expense, and we can save money. It's really a no-brainer. Do you want puddle paving on the left, or do you want permeable paving on the right? Puddles are great to play in, but if you just go into the shops, they're a pain to slip in. So I recommend now, if we're looking at a new development, permeable pave the human traffic areas, not where you think the greatest water will be. The greatest benefit will be avoiding the trip hazards and the liability claims and the pain and suffering. Use permeable paving wherever you like, but specifically target the places people will walk. You can also build it level. You don't need a crossfall. So all those kids going to school don't need spinal problems down the track because we put a 4% grade on the path they walk down twice a day. So have a think about that. But at council now, 70%, give or take, of our capital works footpaths, new footpaths and renewals are done in permeable paving. About 70%. We've been building a few roads, no problems whatsoever. One interesting point, there's a little bit more noise as a car drives down a permeable paved road. It hums a little bit like the tyres on your mountain bikes. Maybe that's a good thing with electric cars becoming more common. Anyway, just something to think about. This was done specifically to preserve those trees nearby in a heritage area. And you might have seen pictures of this before. Intersection that used to flood regularly, to upgrade the pits and pipes to provide the drainage solution was going to cost $1.2 million to run the pipe down to the main system. $1.2 million. We had change out of $200,000 for permeable paving with under drains that feed into soakage systems on a nearby reserve. So permeable paving solution, you think, costs $30,000 more than asphalt for that area. If you're just looking at pavement, you couldn't justify it. Take a look at the bigger picture. That job saved $1 million, and it's not a big job. So we really need to pull back, look at the bigger picture, look at these other benefits, look at the environment, look at the human interaction. This is a worst case scenario. It's the bottom end of a large catchment, so it takes a lot of water. Ideally, you'd build these throughout the catchment. Anyway, we're building these all over Mitcham now. This isn't one of mine, but you can have a look at this online. I volunteer a lot with the TreeNet organisation. Wonderful organisation. If you're not a member, I'd please ask you to get online and have a look at the benefits of becoming a member. Adelaide Oval was redeveloped going back a few years, some fig trees on the northern side. Adelaide Oval is a sacred site. It is a magnificent location. Even the turf there is precious. Bradman's scored a few hundreds on it. But they needed to put some roadways through with the upgraded stands, upgraded capacity to be able to handle fire trucks, basically. So the permeable paving Eco Trihex was used around the outside of the stands, and it was extended to link to the pathways through the parkland to the north of the oval. I had a look at this before the work was done. I wasn't involved in this work at all. It was Alex Game and Dean Nicole did this. Get online, have a look at some more information there. But I was back there last year, and those trees are looking better than they ever have. They're developing more fine root growth. They're probably getting more water with less weed competition. I actually think what we've seen with the root tracks under permeable paving, it's probably a better environment for roots than just bare earth. Bare earth with companion plants is probably the best, but this is intermediate. And we can also irrigate, we can inoculate, we can introduce the beneficial fungi through the pavement surface. It's a wonderful medium to use. Gravel base, concrete edge restraint is critical. You really need to constrain this to contain the screenings so they can be settled and paved. Run a single vibrating plate over the top just to settle them, and you won't get any movement following that. But it does need good constraint of the base and the pavers themselves. You can be creative with this stuff. This is City of West Torrens. I used to work there. It's a local Adelaide council, western suburbs. They wanted to get the benefit of the root deterrent effect around the trees. So they introduced artistic permeable pavement down the street. It's very reminiscent of the City of West Torrens logo, which emulates the River Torrens flowing through the northern side of the council there. You don't need to pave the full area. Ideally, you'd pave 20 to 25% as a minimum of an area with permeable paving to harvest the runoff from the impermeable section. Don't need to pave the entire area, but you can pave in the areas where you'll get the best benefit in terms of allowing supporting tree growth. So I recommend you look at that. And you're probably well familiar with the Sydney Olympic Park site. This was built just before the 2000 Olympics. I've spoken with the people over there a couple of years back now, and they were removing some paving because of changed land use. The original paving is still in perfect condition. No need to remediate anything. And I specifically asked them about issues with tree roots, and they've had no issues with tree roots in permeable paving. That's one of the longest surviving examples in Adelaide, one of the earliest examples, and that's over 20 years now. So it works. So that's about my time up. I'll say thank you again for tuning in. Thank you to the CMAA, to the City of Mitcham, and to the universities, and to TreeNet for the opportunity. Jim has already addressed a couple of these slides with you. I will just recommend to you, if you haven't any resources on permeable paving sitting on your shelf, pick up the CMAA gear offline, download that. But I'd recommend this book to you as well, Permeable Pavements, American Society of Civil Engineers. It's a summary of the state of the art back to 2015. It's a really good investment. Any questions?
And I think Jim's just going to put us back on camera. I think we do have a couple of questions. I might just run through them from start to finish, and if you want to have a bit of a go at answering some of them, that would be great.
Yeah, that was
I'm an academic now. I don't actually need the questions. I can answer them anyway, and the answer is we need more data.
Yeah, That was an absolutely fantastic presentation, Tim. For the audience, I've also set up a link for the Permeable Pavements book that Tim just talked about for those of you interested. So it's available.
But yeah, just for the benefit of everyone that we're here, we might take a couple of questions. Keep in mind, if we don't get through all of them, we will make sure to answer all of these questions in a follow-up email for everybody. So if there's anything we don't clear up today, we'll make sure that there's answers provided to you. But starting from the top, the first question I think is from Ben. And he says, are shrink swell movements of high plasticity subgrades an issue with permeable pavements on an uncompacted subgrade?
No, we haven't found any problems with them as yet. But again, I'd like to see some more research. We've actually started a large-scale project on a highly reactive and extremely reactive site. It won't involve permeable paving. It will involve soakage trenches, so we can get larger volumes of water in, and so we can control them using fire hydrants and things. But that's in its early days. We're just doing background benchmarking. But in moderately reactive, 4% shrink swell per PF change soil suction or less, no problem. The seasonal movement we've been seeing is 30 to 50 millimetres from winter to summer across the board with business as usual pavement and with permeable pavement. But where there are trees involved, the average movement is 5 or 6 millimetres less with permeable paving than impermeable. Where there are no trees involved, it's 5 or 6 millimetres more. So it's a difference of 5 or 6 out of a range of 30 to 50 movement anyway. So there is a difference, but you don't need to factor it in. It's so small.
Yeah, thanks, Tim. I think our next question is from Graham, asking about whether we can use crushed concrete in subgrade or base course as a recycled material.
I would love to see that, but I hesitate. There's a lot of lime. It may be soluble. What other leachates will there be? I need to do some environmental work on that. Yeah, it would be fantastic. There's stockpiles of ground glass in waste facilities even. Crushed glass perhaps might have a use somewhere down the track, either in the bricks or as part of the base. Yeah, we've got to look at the cyclic economy. We've got to look at recycled products. It may even be recycled plastic beads. There are a whole range of options where we need to look at. But yeah, I don't think that research has been done yet.
Yeah.
Jason? Graham also has a follow-up question about what should the distance be from the tree to the base to start minimizing roots from lifting up the pavers?
Yeah, it depends on the location, the soil type and the tree species and the climate. We've proven that roots will track down the outside of a gravel base layer. So what we did in the cases that I presented, we battered the interface down. Some of them were at 45 degrees and some were nearly vertical, and the roots will track down whatever you prepare. So you can fit a tree into virtually any space that's going to have pavement around it. If you pave fairly closely, you'll have to remove some as the tree grows. I'd say look at the mature size of the tree trunk, the species you're planting in that area, find some examples, look at the mature size, and if you were to double that, if you're looking at planting a massive tree, 1 metre thick trunk, I'd say use at least a 2 metre circle to start, probably larger. If you've got a smaller space, consider the species you're looking to plant. But you can pave up to the trunk of the tree, right to the edge, and you can use this system to modify the root growth. But as the trees grow, you'll have to respond. So give them enough space to reach maturity, plus a safety margin.
I think that the pear tree example that you had earlier was quite remarkable with the small amount of spacing.
Yeah, now those pears at maturity, they're going to have a trunk about 300, maybe 350 diameter, and they're in a 600 tree pit. But you saw those large roots, they're not going anywhere, they're just going to continue to expand. So those trees can live out their full life with no roots in the pavement or base locations. So you can have pavement asset life and tree asset life side by side.
Just a bit of a flow-on question while we're talking about this. Jim has asked in the chat, seeing that the vertical root growth under permeable paving, would it be useful to plant a root collar of street trees 200 to 300 mils below the ground level?
No, there's a lot of research done on that. Nursery practices sometimes plant things at greater depth where they're striking trees from woody cuttings and things. Roots are very different from trunks, completely different physiology. The interface between the roots and the trunk needs to be at ground level. If it's too high or too low, it's going to run into problems. So you really need to bring the soil level back to the surface where you're going to plant the tree with a batter somewhere that grades into your permeable base. But tree roots, when you get a tree from the nursery, the level of the potting soil in that pot needs to be at ground level. Don't plant it too deep. The trees generally will suffer.
Yeah. Jason has a question. I think he saw in a couple of images the use of geotextiles, and is asking, he wonders the influence of geotextiles in encouraging the roots to grow further down, and whether that has a role.
That's a good question. We didn't look at that. I know geotextile is great in terms of water quality because it holds a little bit of moisture and the bacteria will survive on there that will bioremediate and treat the water that's coming through. But whether that's sufficient to have an impact, I think it would be minimal, if at all, and I wouldn't expect that it would have any impact. Roots grow through the geotextile with no problem. I've actually got a series of photographs where some roots grow into the geotextile and grow through in that layer. They kind of weave backwards and forwards within the textile and then pop out somewhere else further along. I don't know. I haven't seen any research on it, but I doubt it would make any real difference to the depth.
Yep, so on to the next question. Ben asked, does permeable pavement work as well on sandy subgrades with less than 5% fines?
I've friends and colleagues in Perth who've used a lot of permeable paving. Yeah, it drains incredibly well on sand with very little fines. It's possibly not as beneficial to the tree because of that. The soil doesn't, the sand doesn't hold the moisture as well. But yeah, certainly beneficial. It'll reduce the stormwater issues downstream, provide a little bit of moisture for the trees. Yeah, no problems using it on sand.
Yeah, definitely. That's our experience at the CMAA as well. Gary also asks that, understanding that the civil design obviously dictates the depth of the gravel over your uncompacted subgrade, does a very thick gravel layer start restricting gas exchange?
Surprisingly, very little. Gravel with no fines, angular crushed rock, varies from about 39% air-filled up to about 44%. So nearly half of the volume is air. Diffusion's pretty random, so it's more likely that if you put a greater depth, you've got that self-weight that might compact the subgrade, like a preload of subgrade, and that reduces diffusion. I think a greater influence is water. The main reaction looking at trees is oxygen diffusion in and CO2 diffusion out. Tree roots respire. They take oxygen in, they let CO2 out. The leaves do the opposite, but roots respire like we do. And oxygen diffusion through water is about 1/10,000th the rate of oxygen diffusion through air. So if you've got an uncompacted porous subgrade that's say 40% air, the diffusion will be relatively quick. If that's saturated, if the permeable pavements absorb some rainfall, transmitted some rainfall through, and there's a thin layer of wet soil, that wet soil will actually reduce the infiltration rate by a factor of, it varies 7 to 10,000 times. So I think the moisture influence of permeable paving is probably a greater impact on diffusion than the depth of the gravel. Even a wet layer of mulch will reduce diffusion. We're pretty lucky in Adelaide, and across most of the subtropics in Australia, where we're incredibly lucky with the climate, we get intermittent rainfall with sufficient breaks that the surface can dry out sufficiently. Nature's a cycle; it's always aiming it towards equilibrium, but never quite reaches it from wet to dry. It's a really interesting subject. Good question.
Yep. The next question we've got just a couple more questions. Ben asked, can you comment on structural soils, so uniform ballast with growing medium in the voids, and whether you would typically specify a gravel course above a structural soil layer?
I've read a lot about structural soils, and I've spoken with the professor who developed them, but I don't have any personal experience with them. I know they can work incredibly well to transmit extremely high loads. But if you think of that figure that I just quoted of the void ratio in angular crushed rock, it's between 39 and 44% of volume. And with structural soils, the volume of soil has to be a few percent less than that void so that it doesn't compact between the stone. So you're limiting the soil availability to roots to 35% by volume at most. So it's reducing the volume and the nutrients available to the trees. It may still be plenty, depending on the species and the location. And it's expensive. Transport needs to be made on site. There's a whole lot of reasons why you would or wouldn't use either of permeable pavement or structural soils. It was invented primarily to bear high traffic loads, and permeable pavements developed the capacity that it can do that on low strength subgrade now. So it's possibly unnecessary in a lot of applications to go the more expensive option. Consider from the structural perspective, if you've got a rigid matrix, even a compacted subgrade clay becomes a rigid matrix at 95%. If you get a tree root grows through a fissure or a weakness, a void through that rigid matrix, and if it's sufficiently nourished at its extent that it will expand, you've got an expanding root that can exert several megapascals pressure on a rigid matrix, so it will lift the whole matrix. Under permeable paving, you've got a low strength subgrade, so it will exert pressure on a low strength subgrade which is seasonally wet and dried, and the soil will relieve its stress as the pressure increases with the root growth. Next winter you've got water, reduces the strength, the soil will move around the root, so you won't get lifting of a large, massive, rigid structure. So yeah, interesting. Horses for courses, and I'd keep both on the palette and make a decision on each job.
Yeah, I think we've probably got time for maybe one or two more questions. Obviously, everyone's got places to be, and we won't keep you all here. But I think Penelope asks, as a rule of thumb, and this flows into some of the links that have been posted in the chat today as well, are some types of permeable pavements, so for example, permeable asphalts or pervious concretes or permeable interlocking concrete pavers, are some types of permeable pavement systems better for supporting trees than others?
Really good question. And again, I'd like to see more data, more research, but that void ratio, 39 to 44% for angular crushed rock, that varies. It's much less than that with the permeable paving. Eco Trihex has the largest voids. You can increase the conductance of the surface by increasing gaps. Pervious asphalt and pervious concrete generally have a lower void ratio. It can be down as little as 15%, and it tends to block more quickly. It would certainly be beneficial, and I wouldn't write it off. But the actual research that came back from that slide, the history slide, I expect you'll leave this presentation available on the CMAA website, Jim.
Yeah.
So people can refer to it. That history back in the 70s and 80s from Los Alamos, it was the gravel layer that made the difference. And in their instance, they capped that with a layer of clay. So the actual surface was irrelevant. It was the drying out gravel layer 600 deep below the clay that retarded the root growth. The arborists in the US and the UK and Europe that started working with it under footpaths, a lot of those examples, they used a poured concrete footpath. It wasn't pervious at all. And it still had that beneficial effect. The only case it didn't work was when there was a very high water table, which pushed the roots up shallow. But the surface is actually less critical for root deterring than the gravel layer. And the gravel layer in the US actually worked under poured concrete footpath. So I thought to get this implemented in the initial stages, I thought let's use permeable paving because it comes standard with a gravel base. So it was, let's try this solution. But it's not the actual pavement surface that makes the difference. It's the gravel beneath it that makes the difference.
Yeah, no, thanks, Tim. I think just being conscious of time now, we might sort of start to wrap up. So I want to first of all thank you, Tim, for coming on with us today and sharing your expertise and knowledge. I think it's been a really great opportunity to sort of see a little bit more of the nitty-gritty that goes on underneath the pavement, and how we can actually ensure that our trees remain healthy in an urban context. Just in terms of some minor housekeeping, Jim has been posting a few links for some of our programs at the CMAA, such as our approved installer program. I'd encourage you all to check these out and have a bit of a look. As the industry association, we offer all of our services complimentary. So if you have any issues with your pavements or any questions following on from this webinar, we'd encourage you to reach out to us. I think Jim's going to push out a poll now as well. If you're interested in having our technical team come to speak to your team about concrete segmental pavements and permeable pavements as well, I'd encourage you to click on that poll and share with us that you'd like us to come and speak with you, because once again, as the industry association, we support our great members, Adbri Masonry, Austral Masonry, and our aim is to really try to push some sustainable paving options for your local government area or for your consultancy team. So I'd highly encourage you, if you have any further questions, to definitely click yes on that poll, and we'll reach out to you and see if we can tee something up in the future. But I might palm back off to Jim now.
Just one last question from Becky. She is wondering where she can find some of your papers and the results that you talked about earlier.
I can send you the links if you'd like to put those links
and
through.
I think
might circulate
TreeNet is a great resource as well, isn't it?
Yeah, we will circulate any relevant links after the webinar.
I've got to head off, guys, so I'll say thank you very much.
Thank you for joining us. Appreciate it. All right. Thanks everybody for joining. I'm going to be closing the session now, but we appreciate you for coming along.
Just one last point, we will send an email with any relevant links and any questions that we might not have got the chance to answer today. We'll have a bit of a look back through and make sure we provide all the answers to you. But once again, this presentation will be made available as a recording, so you will be able to go back through and refer to any of the resources or information that Tim mentioned in today's talk.
Yeah. All right. Thanks, everybody.
Have a wonderful day, everybody.